The physical analysis of green coffee can be broken down into four basic categories: size, density, water content, and defect count. Each of these metrics can have a bearing on any coffee's sensory quality and trade value. As such, it's worth the time of any roaster, coffee buyer, importer, exporter, processor, and farmer to have at least a cursory understanding of these important measurements, how they can be obtained, what their causes and effects might be, and to what degree they might be improved upon. Over the next few pages, we'll seek to cover both introductions to broad concepts and to dive deeply into misunderstood corners and clarify complex concepts in order to demystify the physical analysis of green coffee. The Crown is located at 2523 Broadway in Oakland, California. We're a lab and tasting room, as well as an event space and education center. You can read more about us online. Royal Coffee is the parent company of the Crown, family-owned and operated importer in business since 1978 in the Bay Area. And you are on our website right now. Hey folks, this is Chris Kornman, Lab and Education Manager at the Crown, and welcome to the physical analysis of green coffee. This is Chapter 4 in a 4-part series. Visual defects in green coffee can have a significant impact in the way that a coffee roasts and tastes, and can also have financial ramifications in terms of contract approvals and the value of a given lot. Today's course will cover a number of topics related to the physical grading of visual defects in green coffee, including different methods for removal, different grading systems, some additional resources, and we'll cover a number of individual defects one by one. Both their cause and effect, as well as the type of defect that they might be, when they might happen in the process. There are a few main sorting methods for defect removal in countries of origin. Hand removal, either while drying in parchment or after hulling, is quite common in many countries, particularly in areas where either a long tradition of coffee production might exist or where there is inexpensive labor. Talented individuals can clean about 1 60-kilo bag of coffee per day. In some cases, a conveyor belt will pass coffee along a table in front of workers to help keep a steady production pace. Automated dry mill removal typically involves two types of machines. A density table, which is actually covered in Chapter 2 of this series, will help separate foreign objects, chipped pieces, and other low-density coffee from the good stuff by vibrating a particular angle and frequency. The other main device would be an optical color sorter, which are becoming increasingly sophisticated and can use laser and other computer-driven technology to remove discolored coffee within a specified tolerance. The best of these machines are customizable down to the shade of discoloration and the amount allowed per bag, so you can kind of pick and choose your defect count as a dry mill with one of these machines. Some of the priciest and high-capacity units might set you back over $100,000, but this machine can also process hundreds of bags in a day, making it incredibly efficient. While there are established standards for green coffee defects, those defect count standards actually vary significantly depending on the system. The two most familiar systems to most graders will be the Specialty Coffee Association of America and the CQI's format, and then the other format would be the Brazil-New York method. Using 300 grams of green coffee, a grader will pick and categorize different defects. SCA-CQI has identified Category 1, which would be severe defects, of which none are allowed in CQI 85 plus specialty grade, and Category 2, of which there are up to 5 allowable defects in CQI specialty grade. These would be less severe defects. In many of these cases, the defect count doesn't correlate exactly to a bean count. So, for example, while a severe Category 1, one sour bean would categorized as a fully severe defect, it actually would take 3 partial sours to accumulate a single Category 2 defect in this case. The Brazil-New York method, on the other hand, differentiates between what they call intrinsic defects, such as insect damage or shells, that would be defects relating to the beans themselves, and then has an entire category for foreign defects, categorizing differences between different sized sticks and stones, for example. You can find a list of the details on both of these defect grading methods within Annex 7 of Joakim Mutua's Post-Harvest Handling and Processing in African Countries. It's a really great resource. It breaks down a lot of the details of both methods pretty well. There are merits to both of these methods, where the SCA-CQI method places a heavier emphasis on the flavor impact of these defects, and the Brazil-New York method tends to help with securing contracts and protecting equipment. Let's take a quick closer look at the SCA-CQI defect count. And on the left, near the top, you'll see these category 1s and how, for example, full black or full sour or dried cherry and fungus damage, foreign matter, all the defect count equates to 1 to 1. That is, a single found bean in the 350 gram sample equates to a full defect, whereas in that same category it takes 5 severely insect damaged beans to equate to a single defect. And usually I believe that they, to differentiate between the category 1 and category 2 on like partial sour, full sour, or severe versus slight insect damage, it's about 50% coverage. So if more than 50% of the bean is affected, then it would be a severe. And then on the right side in that category 2 section, you'll see how all these different categories of less severe defects are typically in the range of like 3 to 5 counts to equate to a single defect in that category. So one other resource in this regard that's pretty useful, and in fact I've leaned pretty heavily on it for the categorization of this class. And that would be Jean-Nicolas Wintgens' Coffee Growing, Processing, and Sustainable Production. It's a textbook and it's quite dense, but it is a really invaluable resource. So with that out of the way, let's take a quick start to finish tour of the cause and effect of some common green coffee flaws. The pictures that you're going to see today, for the most part, have been meticulously collected and categorized by Royal Coffee's certification specialist, Rosie Quinones, and these were documented in photography by the Crown's creative director, Evan Gilman. And as I mentioned, I've leaned pretty heavily on Wintgens' seminal work on growing coffee. The publication has, among innumerable other useful topics, images, descriptions, and a really lovely and detailed section on green coffee defects, and I've borrowed some of their categorization for this class. I've broken our categories down into 3 for today: pre-processing, processing, and post-processing. So we'll start with the first, going sort of chronologically, I suppose. The main culprits of damage to coffee while on the tree or immediately after picking are insects, genetic flaws, disease, environmental factors, or human errors. Insects like the coffee berry borer will literally burrow directly into the seed, leaving small visible holes. Discolored coffee, often black or brown in color, can result from a number of different factors, most of which occur before the fruit is stripped away. Frost damage can blacken the seed, as can insects like the mealybug or intestia bug, fungi like the coffee berry disease and other afflictions, and even nutritional deficiencies, overripe cherries, or delays before pulping. Withered, wrinkled, low-density coffee is often the result of drought. Among the more reviled pre-processing defects are Quakers, coffee seeds that don't properly react during the Maillard stage of roasting, so that even at a relatively dark roast, Quakers will stand out with their pale orange or khaki-like appearance, and when ground they emit a rancid toasted peanut aroma. These pesky defects are acknowledged to be predominantly the result of underripe coffee. Underripe green seeds will often curl at the edges, giving them kind of a boat or U-shaped appearance. While it's possible to eliminate some underdeveloped seeds in flotation tanks prior to pulping or in grading channels after fermentation, it's far more effective to remove underripe cherries while visibly apparent before processing begins. Otherwise, the roaster must resort to manual removal post-roast. There are a few factors that complicate the presence of Quakers in coffee. Most high-level specialty coffee producers will ensure hand sorting prior to processing, but government regulations or local traditions can also interfere with this. One example might be that at Costa Rican cooperative wet mills, as an example, they struggle to incentivize high-quality picking due to rules that demand that they pay the same to all contributing farmers, regardless of minor qualitative differences in delivery. They actually have to accept some underripe cherries in their processing. This problem is, of course, not limited to Quakers or to Costa Rica. Cooperatives and private delivery stations alike grapple with paying fairly and encouraging excellent quality. Whether paying by weight or by volume, there's often little reason to sort more than the bare minimum without some type of incentive. The uneven distribution of benefits, even when merited by qualitative harvest or sorting differences, can cause rifts in communities who may be unfairly disadvantaged due to poor soil or elevation, for example. There's not really an easy answer to this, and it makes getting perfect coffee fairly complicated. Interestingly, graders tend to find more Quakers in coffees that are dried in the cherry, that is like natural or dry processed coffees, as opposed to those which are depulped, fermented, and then washed prior to drying in parchment. Some may argue that this is a testament to the success of washing process, removing floaters from high-grade coffee. Equally as likely is that high-value washed coffees tend to have better ripe cherry selection than their lower-valued counterparts, which are minimally processed and dried in the fruit. A well-sorted natural coffee prior to drying will most likely produce roughly the same number of Quakers as a fully washed coffee. There's one other point of confusion here for graders. Quakers are only identified once the coffee has been roasted, and not all green coffee identified as underripe may result in a Quaker. Conversely, not all Quakers may be readily identifiable as underripe in prepped exportable green coffee. CQI and SCA recognize underripes as an allowable secondary defect in small quantities, but they also define specialty coffee with a zero tolerance for Quakers. Flavor attributes attributed to Quakers and underripe coffee tend to differ as well. A single Quaker may taint a sample and create inconsistencies from cup to cup on an evaluation table and elicit notes ranging from peanut or peanut skin to fatty or oily. However, underripe has been classically defined as the cupping table as harsh or rough, generally referring to an astringency accompanied by a sort of fresh hay or grassy flavor. Ultimately, my suggestion would be that the solution to this problem is singular. Eliminate underripe coffee cherries from the lot prior to processing and or drying. If you'd like to read a little bit more about Quakers, Andy Trindle has a really informative article published in Roast Magazine a while back that I believe is accessible for free on the internet. Aside from Quakers, arguably the most common pre-processing flaws in green coffee tend to be genetic or developmental defects. Genetic flaws take the form of pea berries, shells, sometimes called elephant ears, don't confuse that with the oversized elephant beans, and triangular or tricorner seeds. It's possible that the variety of coffee may have an effect on the frequency of genetic flaws. Anecdotally, I've noticed that SL28 and SL34 coffees most frequently grown in Kenya tend to have higher probability of containing shells. In the field, I've heard it occasionally theorized that genetic flaws in green coffee might be exacerbated by nutritional anomalies, like the presence of too much phosphorus in the soil, or in applications like fertilizers, for example. Coffee typically produces 2 seeds per cherry, and if the pea berry is the single seed iteration, triangular seeds and shells represent the other side of the genetic defect coin. Triangles are caused by an extra seed or multiple extra seeds. In extreme cases, I've seen images of 8 or more seeds per cherry, but that's very rare. Much like the pea berry, tricorners will roast differently from their more commonly shaped counterparts, usually absorbing heat more rapidly, thereby imbuing the batch with some smoky off flavors. That would be their primary, risk, is that they're contributing these sort of roasty notes to an otherwise well-roasted coffee. Similarly, shells, perhaps the largest nuisance for roaster of the genetic flaws that we've talked about, are the result of a phenomenon known as false polyembryony. Polyembryony is simply a term that means multiple embryos developing within a single seed. but so-called false polyembryony is the anomalous occurrence of an abnormal dual embryo instead of the two independent embryos. And so these shells can present problems for the roaster due to their low density and their propensity to break or separate during hulling. Like triangular seeds, they tend to roast more rapidly than their properly developed counterparts and can impart some minor off flavors of carbon during the roast. In many cases, properly calibrated density tables and screen sorters at the dry mill can effectively sort out all of these defects. So we covered peaberry a little bit in the density section of this four-part series, but it's also worth talking about in terms of physical anomalies. The peaberry, referred to caracol in Latin America, is a genetic anomaly that occurs in about 5% of most coffees, resulting in a single seed rather than the facing pair inside the cherry. Once worked with a farmer in southern Zambia, and he had a unusually high occurrence of peaberries. It's like something like 20% of his harvest was peaberry. And it's hard to know exactly what that might be, but it could be a combination of factors, including a lower elevation than usual for some of the varieties he was growing, and relatively arid conditions. He had to irrigate quite a bit, and he was using a pretty heavy fertilizer application. Peaberries garner an unprecedented amount of attention in certain regions of the coffee trading world. Anyone who's ever heard of a coffee from Tanzania has a high likelihood of it being a peaberry. This perhaps might have to do with peaberry's naturally high density, which make the coffee more resistant to fading during transit, which has traditionally been a problem, an unfortunate risk in Tanzania. The hot, humid climate at the main port city of Dar es Salaam is not friendly to the coffee, and delays there are really common for a lot of reasons, including poor road conditions and complicated or corrupt bureaucratic hurdles, and an internal auction system that really seems to, in some cases, incentivize holding the coffee rather than selling it. At any rate, the affection for these, funny little round peaberry seeds could just be the visual appeal. They're objectively adorable and often pleasantly uniform, both before and after roasting. It's possible, but generally disputed, that these peaberries might have more concentrated flavor. They definitely present challenges in drying and roasting, as their shape, size, and density don't absorb heat in the same manner as a flat bean. They're small and round and compact, and make the craft of roasting them a little different than other coffees. So let's move on to our processing errors now. Defects that occur during processing are generally the most commonly encountered, and by and large the result of some combination of human and mechanical error. Very frequently chipped and sometimes broken coffee will end up in export grade. Chipping can happen both at the pulper, where the affected area will often become slightly discolored during fermentation. It can also happen at the dry mill, usually during parchment hulling. The discolored area of the pulper damaged coffee rarely, but sometimes might lead to an infection. And broken beans and those with significantly increased surface area due to major chipping will lead to minor roast defects. That being said, minor nicks from the pulper and the huller, I would say, are rarely cause for any serious concern. And then, of course, foreign matter, being anything that's not coffee found in the batch. I think every roaster has a story of something that they found that's unique and different. A wide range of potential here for problems. The most high risk would be solid material that could potentially ruin a grinder. Coffee that's improperly hulled or pulped so as to leave full coffee pods, that's the defect term for the whole dried cherry, or significant portions of the cherry skin and or parchment stuck to the seed, I would say is probably a more serious concern than nicked or chipped beans. These conditions can sometimes harbor fungal infections and will never roast properly. I've definitely, seen or heard some people trying to roast coffee in parchment, and I wouldn't recommend the practice. It's a little bit more combustible than green coffee, and I think it rarely turns out well. From time to time, samples show up in labs that have not been hulled from their parchment, and this will give you a rare and somewhat painful opportunity to experience what it takes to hull coffee by hand. It's not terribly fun and pretty time-consuming and tedious. A few other defects worth noting here. Silver skin discoloration can occur during fermentation and honey or cherry drying. So basically any processing style where the fruit of the coffee is in contact with the seed for extended periods of time. The result will be kind of a reddish hue. I used to hear people refer to this as foxy. And generally speaking, it's only skin deep. It really only affects the silver skin, and generally has, in my experience, very little effect on the final flavor. Though it may affect the coffee's value due to its, less appealing appearance. Usually, like I said, this is resulting from increased contact time with the fruit. However, in some cases, it can indicate the presence of dirty water during fermentation or washing, which will definitely have a more pronounced effect on roasting and taste. There's also a couple of severe defects that are endemic specifically to fully washed coffees, resulting from the additional steps of wet processing that they're going to undergo before drying and milling. The washing channels used after pulping and fermentation are the first step in grading coffees, separating floaters, a specific defect, which can include underripe seeds, drought-affected coffee, and other developmental anomalies, from sinkers, which would be the high-density coffee that's of good quality. Not to be confused with sinkers, fermenting coffee can also result in stinkers. That would be coffee that's over-fermented and emits an acetic or briny aroma and flavor. Frequently, this is the result of some combination of delays between picking and processing, or dirty fermentation tanks, or fermentation times that are too long, or maybe even too short. Also, not properly agitating the mass of fermenting coffee can result in pockets of over-ferment and otherwise unaffected batches. Regardless of processing type, however, the most serious processing defects are almost always drying related, in my opinion. Post-harvest drying is, I would say, the most critical stage in quality preservation and management, and we do cover this a bit in Chapter 3, which covers water activity and moisture content. And errors during this hypersensitive process tend to be magnified. Under-dried coffee will be soft and sometimes even pliable, often a darker green in appearance, while coffee that's had interruptions in drying may appear blotchy. Frequently, these coffees will taste musty, swampy, or vegetal, at least until they begin to rapidly age and then start to taste like cardboard and burlap. Traditionally, these aren't visual defects that are sorted out by people or machines, despite their severe impact on flavor. Drying coffee, whether in cherry, as depulped parchment, or wet-hulled green, it exists in a constant state of threat of microbial activity. Mold and fungi, as well as bacteria and other infections, may occur as the wet coffee dries, particularly if it's not being turned frequently to promote even drying and good airflow. So it's possible to spot some of this fungus visually, but some microbial damaged coffees remain latent until roasting, like the potato defect. If an infection is particularly bad, brownish spores might even appear on the surface of the seeds. And I've seen people use black lights to spot fungus damage, but black lights will also return false positives for things like pulpernicks and less consequential drying anomalies and a few other non-severe defects. So it's not a 100% reliable system. And I continue to argue that it's impossible to overstate the importance of even well-ventilated drying scenarios. Defects that occur at this stage are not only unpleasant to taste, but in some cases they can actually present a real health risk. Mechanical dryers, known as guardiolas in Latin America, were developed as an alternative to labor-intensive and climate-susceptible patio or table drying. When properly loaded and when temperatures are maintained at relatively low heat, these machines can efficiently turn and dry pretty large quantities of coffee. Maximum operating temperature of 45 to 50 Celsius, or about 113 to 122 Fahrenheit, is sort of widely acknowledged as like the safe upper limit. Many studies suggest that 35 to 40 Celsius, that would be like 95 to 104 Fahrenheit, might be the best range in terms of quality preservation. Higher operating temperatures have been shown to damage cellular structure of the coffee and negatively impact cup quality. An unintended dryer can easily over dry and even begin to roast the coffee, resulting in green coffee that appears pale brown in color and tastes woody and bitter. Even if a coffee makes it all the way from picking to shipping with no problems, there are still risks. Beetles are a notorious pest, chewing their way through dried coffee and reproducing prolifically. Storage insect damage holes tend to be a lot larger than those from insect damage that occurs in the field from the berry borer. Coffee infested with beetles or with moths or worms that like to eat the jute bags while in storage must be quarantined. In some cases, freezing or cutting off the oxygen supply by completely sealing off the entire lot is necessary to eradicate these menaces. Poor conditions are the other main culprit of storage-damaged coffee. Hot and humid conditions can exacerbate aging. In especially wet conditions, coffee might reabsorb water and fade in appearance as well as flavor. Black spots can occur if the coffee's been poorly dried, and pockets of water within the bean rot. And of course, mold can develop on the surface of the coffee as well. Stable storage conditions will help prevent these defects easily. Dried coffee, whether in parchment or green, prefers environments at or around 65 Fahrenheit, that's 18 Celsius, with moderately low, about 40 to 60% relative humidity. As with many of the risks across the supply chain, preventative measures are significantly more effective than after-the-fact fixes. It's not rocket science. Good practices and attention to detail are crucial. A well-oiled feedback loop completes this picture. Growers, processors, and millers who communicate well with their exporters, importers, and roasters will have a better understanding of expectations and where the gaps in the armor exist and how they can be remedied. This is the conclusion of a 4-part series called The Physical Analysis of Green Coffee, and the 3 other parts in this series are also available online for digital learning. Whether we're dealing with moisture content or density or screen size or the physical defect count, quality and value can be improved across the board by using well-calibrated equipment, employing attention to detail, and using the physical analysis of green coffee to augment its cupping score. Ultimately, well-graded coffee can help to ensure that growers, traders, roasters, baristas, and coffee drinkers alike receive the intended quality at the appropriate price to improve the sustainability of coffee production and consumption. You can, of course, always visit royalcoffee.com and check additional resources there, whether it's crown jewels or information on the crown itself, or our blog for further information and educational materials. And you can always come visit us at 2523 Broadway, or email us at info@royalcoffee.com, or dial the number below to get in touch. Look forward to hearing from you, and thanks for listening.